Okay, so let's move on to the important section, which is Iupac nomenclature of organic compounds. Let's see how to name organic compounds based on the rules which is put forward by the International Union of Pure Applied Chemists. Before that, if you have any questions, what we discussed up to this point. Okay, right. Now, naming of organic compounds is done as per the rules which is put forward by the International Union of Pure Applied Chemists. It's a union of chemists where different countries' scientists are present because it's important that we have a common language of naming organic molecules or whatever molecule, whatever organic or inorganic molecules. But here you're focusing on the organic molecules because the thing is, say a scientist in in France, if he discovered a molecule and if he names in French, we will not understand it, right? So likewise, a scientist in Japan, if he discovered a substance and he used a Japanese name, others will not understand what it is. So the purpose of this union, you have the chemists from all over the world, all the countries are present. So they are not their job is to create this common language. So we know from any country, if you say pentane, they all know this is the molecule pentane. Or if you say hexanol, they know this is hexanol. So irrelevant of the language you speak, this is where all get united into one language, right? So we know if you say hexane 2-ol, everyone will know what it is. So what are the rules? Let's see, what are the rules of naming an organic molecule? Any organic compound, the name of any organic compound consists of three parts. You have the first name, and you got the middle name, and the last name. It's like a name of, it's like our names. We have three parts, right? You had the first name, the middle name. First name may be your family name, middle name is your name, your last name is your father's name or whatever. Some people write in different orders. So likewise, it's important that when you're naming a compound, for example, like your name, say you have a certificate, your certificate will have, your A-level certificate will have all the 3 or 4 or 5 names, right? If your name has 5 parts, your entire name will be there. Say, right, for example, if you just give a certificate with one name, you only use your middle name, that won't be a valid certificate because the reason there will be thousands of people with that same name, right? So it's very important that when you are specifically mentioning a specific person, you have to use all the 3 names. If you miss one of the names, that means many people may claim to be that person. So likewise, when you're naming organic compound, it's vital that you use all the 3 names. Suppose if you miss any of the name, out of 3 names, if you miss any of it, your whole naming or the whole molecule naming will be wrong. Even though the part of it is right, you get the whole thing wrong. Right, so let's see what is his first name, middle name, and last name means. So in fact, the first half of this lesson you have already done for all levels, but I'm going to start from the very beginning. And we'll go into advanced naming most probably in the next lesson, right? Today I'll be discussing about the basic naming, right? Basic, very simple molecules. So the first name will tell you the number of carbon atoms in the main carbon chain. Remember, the first name will tell you the number of carbon atoms in the main carbon chain. I will shortly explain what is this main carbon chain is. It's not the number of carbon atoms in the molecule, right? That is not correct. To say first name is number of carbon atoms in the molecule is not correct. There's a difference between the main carbon chain and the number of molecules. Shortly, I'll explain. what is this main carbon chain is. So if there's one carbon, we say meth. Two carbons, eth. It's very important you know how to uh, write the names, the spellings properly. Three carbon, prop. Four carbons, but. See, this is but, not but. It's but, right? Because it's written as but it's pronounced as but. Right? You don't write but like this. This is not correct. Right? But is but here, right? And five carbons, pent. Six carbons, hex. Seven, hept. Eight, oct. Right? You have heard about octane. 92, 95, oct is 8, right? C9, none, and I stop with 10, dec. It goes on, 11, dodec, but you don't need to know beyond 10. 10 is maximum, right? For your level. That's the first name. The middle name will tell you about the nature of the carbon-carbon bonding. Carbon-carbon bonding nature. If the molecule contains carbon-carbon single bonds throughout, the middle name will be an, An. If there's a carbon-carbon double bond, we say N. Triple bond, in. Alkane, alkene, alkyne. Alkane, N. Carbon-carbon single bond. Double bonds, N. Triple bond, in. That's the middle name. Right, so this is the first name, middle name, and you got the last name. Last name will be the functional group. We discussed last week about functional groups in detail. I hope you remember. And I listed the functional groups in the priority order. Next week, I'll explain how this priority is important. So there you know, if you have a carboxylic acid, we say oic acid. If you have aldehyde, we say al. If you have alcohol, we end with on. If you have ol. If you have a ketone, it's on. It's not one. It's written as one, but it's pronounced as on. If you have a cyanide group, we say nitrile. Last week, I listed all the functional groups that you come across, and their IUPAC name, the last name. There are some molecules where there are no functional groups listed. The listed functional groups are not there. In that case, that means only carbon and hydrogen is present. If only hydrogen is found, then we end with the letter E. We just simply end with the letter E if there is no functional groups listed. Just say E. Right? Clear? This is the basic rule of naming a molecule. Let's try to apply this rule. So when you come across molecules, it can be in the form of structural formula, or it can be in the form of skeletal formula. Of course, molecular formula, if it is given, you cannot name it. Molecular formula, you have, if they say to name a molecule, it's a must that you give the molecule in structural or displayed formula. Because, say for example, if I say C4H10, this is C4H10. If I tell you to name C4H10, you can't name it. Why? Because I can draw various isomers for C4H10. I can draw in various structures. See, this is also C4H10. Right? This is C4H10. C4H10. So which molecule you are meaning here? So you can't name it. By looking at the molecular formula, you can't name. Right? So you have to know the structural formula. So here you have 1, 2, 3, 4 molecules. So it's but. And carbon-carbon bonding is single bond. You can see if you draw the displayed formula, you notice This carbon has 4 bonds. This has 4 bonds, 4 bonds, 4 bonds. All have 4 bonds, 4 single bonds. So it's N. And there's no functional groups here. Butane, right? It's not butane, it's butane, right? And likewise, you have, say, CH3, CH2, COOH. If the functional group is a carbon-containing group, you have to count that carbon as well when you're naming the first name. The functional group is a carbon-containing group. You have to count that carbon as well. So this is 3 carbons, 1, 2, 3 is prop, and carbon-carbon bonding is single bond, so is an oic acid, propanoic acid. Oic acid is the IUPAC name for the carboxylic group, right? So remember, between the first name, the middle name, and the last name, there's no space whatsoever. Just written as one. There's no but, you don't leave a space. You don't leave a space in between, right? Except in propanoic acid, because oic acid is 2 words. So there is a space there, right? So let's write some of the examples. I have covered the first basic rules. I have summarized all the rules here. So I have explained the name consists of 3 parts. The first 10 I have named, the middle name, the last name, right? So I have done this part. Let's try to apply that into some molecules. Let's name these molecules, very basic ones, which you have named for O levels as well. Copy this and name it. So what's the first one? Butane. Second one, prop and oic acid. And then you got 3 carbons and all. Prop and all, propanol. There's no space. Prop and all, propanol. And how about this molecule? What is its functional group? We discussed about this last week. CHO functional group is what? It's an aldehyde functional group. See, aldehyde functional group. So aldehyde functional group, we end with the suffix al. Al. So how many carbons here? 1, 2, 3, 4, 5. Pent. You draw the displayed formula, you notice all carbon-carbon bonds. Carbon-carbon bonds. All carbon-carbon bonds are single bonds. So pent and al. This is the aldehyde, which is C double bond OH. The displayed formula last week of all the functional groups. Yeah. Okay, so let's move on to the next rule. Let's see. I said the first name tells you about the number of carbon atoms in the main carbon chain, right? So let's see how to identify the main carbon chain. Now, when it comes to simple molecules, that won't be an issue. But if you have a complex molecule, like with various branches and various different functional groups, then it's important that you identify the main carbon chain. There are 3 rules to identify the main carbon chain. The first rule is that the main carbon chain should be the longest chain. main carbon chain should be the longest chain. For example, I'm going to draw this molecule this way, right? Okay, so now I'm not going to show the hydrogens just to save time. I'm not going to draw all these are hydrogens attached to carbon. It's a hydrocarbon, right? Now I'm going to highlight 4 chains with different colors, 4 different colors, and tell me which color is correct for the main carbon chain. What's the first rule? Main carbon chain is the longest chain. So which is the longest chain? Hold on, there's something wrong with my pen. 1 second. I did still mark. Let me mark this as well. You have green, light blue, purple, and red. Which is the longest chain? Therefore, which is the main carbon chain? Which color? Green. That's right. Why? I want everyone to respond, please. Need to know that you're, active in the class. Understand what I mean? Right. So it's okay. Even if your answer is wrong, just correspond with me. That's very important because I know then you are alert in the class, right? And you said the green color. That's correct because that is the longest chain. You have 1, 2, 3, 4, 5, 6, 7, 8 carbons in the green one, and the red one you have 1, 2, 3, 4, 5, 6, and the blue one you have 1, 2, 3, 4. So the longest, and the purple has 1, 2, 3, 4, 5, 6. The longest one is the one which has the highest number of carbon atoms. That's the first rule. Longest chain. The second rule is that the main carbon chain should have the main functional group attached to it. I'm going to do a small change now. That means it should be the longest with the main functional group if there is a functional group. So I'm going to put an OH group here, which is a functional group. So now tell me which is the main carbon chain. I'm going to do a small change to this. I'm going to include this chain as well. Which is the main carbon chain now? It should have the functional group in it. Along with the functional group, the main functional group should be there, plus the longest. Which one is that? Yeah? Everyone, even if you go wrong, it's okay. Best way to study is by doing mistakes, because failure is part of success. It's not opposite of success. Failure is part of success. That's right, it's blue. How about others? Everyone agrees blue, because you can see 1, 2, 3, 4, 5, 6, 7 carbons. The red has 6 carbons. The light blue will have only 4 carbons. And you can't take the green now because it does not have the main functional group attached to it. So it should be the longest. It should have the main functional group attached to it. And plus, it has to also have maximum number of subsidiary groups. What are subsidiary groups? Subsidiary groups are the alkyl groups, like CH3 groups, C2H5, alkyl groups. I'll be explaining about alkyl groups shortly. Carbon-containing group, which means if I take the green, the blue one, you have the CH3 group standing out here, and the C2H5 group standing out. So we have 2 attachments to the main carbon chain here, right? So you should have maximum number of attachments or the maximum number of subsidiary groups attached to it. Then it becomes the main carbon chain. Got it? Right? So there are 3 rules to identify the main carbon chain. Should be the longest, should have the main functional group, and maximum number of subsidiary groups. Maximum number of subsidiary groups, meaning attachments. So this is how you identify the main carbon chain. Why the main carbon chain is so important? Because the first name will tell you the number of carbon atoms in the main carbon chain. It does not tell you the number of carbon atoms in the molecule. The first name will tell the number of carbon atoms in the main carbon chain. Therefore, this molecule, this specific molecule, has 8 carbon atoms, right? 1, 2, 3, 4, 5, 6, 7. Sorry, 7 carbon atoms. So therefore, this molecule should be named as hept. And overall, the molecule has 9 carbons. Sorry, 10 carbons. That's 1, 2, 3. So therefore, it is not a dec, it is hept, because we don't count all the carbon atoms when it comes to a complex molecule. Naming, we count only the carbon atoms in the main carbon chain. That is the importance of identifying the main carbon chain, longest chain, main functional group, and maximum number of subsidiary groups. So once you identify the main carbon chain,